Here's another set of problems having to do with programming a pump, an IV pump. So first of all, I want to show you that this is normal saline. They call it normal because it has the same amount of sodium chloride as blood does. You can see here each 100 mils, and this is really tiny on the bag. Each 100 mils contains 0.9 grams, which is where you get the 0.9% sodium chloride. And here's the one for, this one is 5% dextrose and 0.9% normal, well, 0.9% sodium chloride is normal saline. So this is what it says on this little thing here. So each 100 mils contain dextrose, 5 grams, and sodium chloride 900 milligrams, which is the same as 0.9 grams. You can actually figure out how many calories this thing is by just multiplying the 5 grams by dextrose is a carbohydrate. Carbohydrates have 4 calories per gram. You might remember that from your nutrition class. So you can actually figure out exactly how many calories if you ever needed to do that in a math question, say for example. Here's an IV setup. This is, you've probably seen this before. This is a simple IV setup. It's just a gravity IV, but it's one IV. There's nothing hooked onto it or anything like that. Here is a pump. The pump has two things, the rate and the volume to be delivered. The rate is always in mils per hour, and the volume to be delivered is always in mils. Now, the pump doesn't know what you're putting through it. The pump doesn't know what medication you're putting through it. It doesn't know anything but mils per hour and volume to be delivered. So this is a piggyback situation, and what you have here is this IV, which has probably medication in it. This IV, which has medication in it, is hooked in to the primary IV. And since it's higher, it's going to go first. And then it's hooked into the pump down here after the bifurcation for the piggyback. So the pump is going to pump away at the rate that it's going to pump at, but it doesn't really know whether you're putting in the medication or whether you're putting in the primary IV. It's just that you are going to program the primary IV would be here, the piggyback IV would be here. When the piggyback is finished, when the volume to be delivered for the piggyback is finished, it reverts back to the primary IV. You'll learn a lot more about this as we go on, but I just want to let you know that it's a good practice to put the volume to be delivered. Say, for example, if you have this whole liter bag, put the volume to be delivered as something less than a liter, like say 950. So if you put 950, then you have a few mils. See, the pump is going to start beeping at the end of when the volume to be delivered has been delivered. And you don't want it to be completely empty, and then you have to scramble around to get a new bag. So if you put it like a few mils ahead of when it's going to actually be empty, that's a good practice, because then you have a little bit of time to get a new bag and hang it and all that jazz. Okay, so here we have problem number 1. The patient is to get 1 liter of D5 normal saline over 6 hours. Set the pump. Now remember, 1 liter is 1,000 milliliters, and this pump only deals in milliliters. Okay, this also is hours, not minutes, so that's good. We want it to be hours. So here we go. It's very simple. Total number of milliliters over total number of hours equals mils per hour, which is going to go in here. So what we have is 1,000 milliliters and 6 hours. So you end up with 166.6, and you can actually sometimes put the 0.6 in here, but it doesn't matter as far as these math questions go. So we have 166 here, and then the volume to be delivered, you can either make the answer be like 950, or you can make the answer be 1,000. It doesn't matter. Either answer will be correct. Another problem, 500 milligrams IV in 50 mils of D5 1/2 normal saline in 30 minutes. So one thing you need to understand is that this 500 milligrams does not matter to the pump. The pump doesn't care what you put in the bag. All it wants to know is the volume right there. So we have 50 mils in 30 minutes. So we want to know how many mils that's going to be in an hour. So it's this kind of a setup. Here's the ampicillin, and this is the normal saline that you would hook it onto. But what the question is asking is simply, what we're going to set the pump for this piggyback. So if we have 50 mils in 30 minutes, in half an hour, then what are we going to set the pump for the full hour? And the answer is we have to set it twice as fast so it delivers the whole 50 mils in 30 minutes. So the rate ends up being 100, and the volume to be delivered is 50. So when 50 is delivered, then it's going to go back to this. It's going to go back to the big bag, the primary bag. After After 50 has been delivered, it's going to go back to the primary rate, whatever rate you put in here. But we have to make this 100 so that it goes in 30 minutes. Next question. The order reads, give Levophed 3 micrograms per minute. Available is 500 mils D5W with 2,000 micrograms of Levophed. Okay, so there's really no way other than this, I think, to solve it. You want to solve for mils per hour. That's what you want. So you look at mils, and you have mils per microgram right here, microgram and mils. Then you have micrograms per minute, and minutes per hour, which of course you know is 60. And so then we cancel, and we end up with mils per hour. Okay, so then our answer ends up here is the 60 minutes and 1 hour, 4 micrograms. So we fill in our numbers. We have 60 minutes in an hour, of course we know that, and 3 micrograms in 1 minute from here, 500 milliliters in 2,000 micrograms. There's that. And it ends up being 90,000 milliliters in 2,000 hours, which ends up being 45 mils per hour. That is our answer that we're going to put here, 45. And the volume to be delivered is going to be this, the 500, unless they stop it sooner than that. So that's the answer to that one.